Hello students, in last lecture we have studied about fundamental particles of an atom. Today we will discuss two from them. Let's see the content list of our today lecture. Number 1 is discovery of electrons and number 2 is discovery of proton. These are our two topics. In late 90s, J.J. Thomas, which is a physician, did a practical with the help of discharge tube. Discharge tube is like a tube light which has two terminals, one is negative and second is positive. Negative terminal is attached with negative terminal of battery and positive terminal is attached with positive terminal of battery. Negative terminal is called cathode and positive terminal is called anode. This discharge tube is filled with a very light pressure gas. After connecting the anode and cathode with negative and positive terminals of battery, J.J. Thomas observed a light rays start coming from cathode towards anode. As we know, opposite charges attract each other, so cathode has negative charge and the rays starts coming from cathode towards anode. It means cathode has negative rays because they are going towards anode positive charge. Let's write this experiment in a healthy manner. In 1887, the British physician J.J. Thomas discovered the electrons, by which he used a discharge tube which consisted of a glass tube. Electrode is connected to a high voltage source, a vacuum pump. Let's start with the content list of this experiment. Number 1 is procedure, 2 is observation, 3rd is result, and 4th is describe properties. Start with procedure. Any gas is introduced in a discharge tube. A low pressure of 10 to 4 atm atmospheric pressure is maintained by evacuating the tube with a vacuum pump. A current of high potential is passed between electrodes. Electrode means anode and cathode. Let's see the observation of this experiment. Streaks of blush light extending from negative electrode cathode toward positive electrode anode were observed. Number 2. The rays appeared to travel in straight lines from the cathode to anode, cause the wall at opposite end of the tube glow where they strike. These rays were called cathode rays. Thirdly, he observed these rays were deflected towards the positive plate in the electric and magnetic field. Let's sum up the result by the help of observations and experiment. These rays consisted of negatively charged particle. The name electron was given to these particles. The discharged electrons were obtained irrespective of nature of cathode or the gas in the gas tube. This proves that electrons are constituents of all matters. Let's see the properties of cathode rays mean electrons. Number 1. Path. The cast shadows of objects placed in the path towards the anode, providing that they travel in straight lines. Number 2. Material particles. They cause a light paddle wheel to rotate revolve, showing that they particles. Number 3. Effect on some material. These rays, although invisible, cause some materials to glow or produce fluorescence. Number 4 is deflection in electric field. They are deflected toward the positive plate in electric field, showing that they are negatively charged particles. Number 5. EM ratio. The charge mass ratio of the cathode particle is 1.7588 rays 10 to the power 8 coulomb per gram. Same for all electrons regardless of any gas in the tube. Number 7. Mass charge. Mass of an electron is 9.10 raised power minus 31 kg. It has a charge of 1.022 10 raised to the power minus 19 coulomb. Number 8. Processing kinetic energy. They can produce mechanical pressure indicating they possesses kinetic energy. Let's move towards our second topic, discovery of protons. Protons are discovered by a German physician which name is Goldstein. Goldstein used a similar apparatus like J.J. Thomas done. He observed another type of rays in discharge tube which comes from anode towards cathode. Because these rays are attracted by cathode negative terminal, so he gave them the name protons or anode rays. These rays give a red glow in left corner of discharge tube. Like electron discovery, I am starting with procedure of this experiment. In 1886, a German physicist Goldstein performed an experiment to discover protons using discharge tube with perforated cathode containing a gas at low pressure. Current of high potential was passed, same like we used in electron discovery. Perforated cathode means holes in cathode so that anode rays can pass and can produce red glow in left corner. Observation: rays consisting of positively charged particles traveled from anode to cathode. Result: the mass of the positively charged particle was equal to the mass of negatively charged particle electron. The name proton was given to the positively charged particles. Let's see the properties of protons or positive ray called anode rays. Number 1. Path. These rays also travel in straight line from anode to cathode. Number 2. Deflection in electric field. These are deflected towards negative plate when passed through an electric field, showing that this carries a positive charge. EM ratio. The charge mass ratio of positive particle is much smaller than that for electron. It varies with the nature of gas in the tube. Charge: it has charge of 1.6002 10⁻⁻19 coulomb. Electrons and protons have same charge, but electron has negative and proton has positive charge.